Do humans actually have the technology to reach distant stars? For as long as we can remember, humanity has dreamed of leaving Earth and traveling to the stars. The moment we first looked up at the night sky, we realized something extraordinary. Out there lies a vast cosmic ocean, far beyond anything our minds can truly grasp. At least once in our lives, we've all imagined the same thing. Leaving the solar system, crossing the dark emptiness between stars, and setting foot on worlds no human has ever seen. But the further we dream, the colder reality becomes. We've sent probes to the edge of the solar system. We've observed galaxies billions of light years away, and yet the only place humans have ever set foot on is the moon. And that happened more than half a century ago. That alone shows how massive the gap really is between observing the universe and actually traveling through it. The real challenge was never just about building spacecraft. It's about energy. Every dream of reaching the stars eventually comes down to one question. What can possibly provide enough energy to take us that far? For most of human history, our civilization has relied on fossil fuels. Coal, oil, and natural gas powered everything. They built industries, lit up cities, and fueled economic growth. But when it comes to interstellar travel, these energy sources reveal their limits almost instantly. Even if they could last for hundreds or even thousands of years, that's still nothing compared to the scale of the stars. And as technology advances, our energy consumption only increases. The more advanced we become, the faster we burn through what we have, which means the dream of reaching the stars can't rely on what lies beneath our planet forever. That's why humanity turned to new energy sources: solar, wind, and hydroelectric power. These technologies are crucial for Earth's future. But for interstellar travel, they are still far too small. They can sustain a civilization on a planet, but not push a spacecraft across the stars. And that's where a new idea begins to dominate the conversation: controlled nuclear fusion. The same process that powers the sun for billions of years. A process capable of releasing energy far beyond anything we currently use. If humanity could truly master it, it could become the greatest energy breakthrough in history. Not just for Earth, but for traveling far into the universe. But there's one problem. We still don't fully control it. So far, we've only managed short bursts of controlled fusion, lasting seconds, or at best, minutes. Turning that into a stable, long-term energy system is still a very long road ahead. In other words, the dream of reaching the stars isn't dead, but it's still trapped by the limits of energy. That's why scientists have started thinking even further, more radical, more daring ideas. What if we don't travel faster, but instead change space itself? Bending space, folding time, traveling through wormholes. Shortcuts hidden within the universe itself. For now, these ideas remain mostly theoretical, but they reveal something important. When distances become too vast, we may have to rethink how movement works. The future of interstellar travel might not be about building bigger engines, but understanding space and time itself. And that's what makes this question so fascinating. It's not just about how far we can go, but about the limits of human civilization. Will we remain forever bound to a single star? Or will we one day find the energy and the technology to finally reach the stars? The answer may not come in years, or even decades. Maybe not even within our lifetime. But human history has always been the story of small beings, daring to dream far beyond their limits. If this made you think, share this video and leave your perspective below, because the biggest question of our future may not be whether we are alone,